Welcome to another episode of Ken Training. Today's training, what we're going to do is we're going to fully do a deep dive into the residential home water supply system. So the water entering into the house. What should the pressure be? How can you control it? And things of this nature. Generally speaking, the range that you want to have is somewhere between, let's just say, 40 and 60 psi. Pressure reducing valves, when they come, when you purchase them, usually they're preset at 50 psi. My pressure reducing valve at my residence is completely bad, and it's been bad actually for years, and I've known about it. And we've been using the water in the house, and we've been getting by just fine with it, even in the condition that it's in, which is in a failed state. Now, when you talk about the pressure reducing valve, there's two things that the valve does. Two things that the valve is supposed to do. Number one, what it's supposed to do is it's supposed to take the incoming street pressure. Let's just say it's 110 psi, and it's supposed to knock that down. Actually, let me write this down. So I'm going to be doing a board example here, and I'll go over the numbers. But let's just say from the street that this here is 110 psi. And now after that, going into the house, let's just put in, for our example, 50 psi. So it's going to knock it down about half. The pressure reducing valve is going to knock it down about half. So that's the first job of the pressure reducing valve, is to knock down the pressure from the street pressure to what you want your house pressure to be at, and you can control that by adjusting the stem on the pressure reducing valve. That's the first action. The second item that the pressure reducing valve does, depending upon the design of the pressure reducing valve, but I believe all of them or most of them have it, is what's called thermal expansion. Now, thermal expansion is when you take your incoming pressure, known pressure, let's just say street pressure of 110 psi. You go through your pressure reducing valve and it goes to 50 psi. Then, when you use the water within the house, you take a nice hot shower. Perfect example. Take a nice hot shower, you deplete the water that's in your water heater, then you're done with your shower, you shut off the hot and cold. And now when you shut off the hot and cold to your shower, all the water in the house is in a static condition. There's zero flow, it's in a static condition. But you've depleted your hot water heater, and the thermostat on the hot water heater has recognized that the temperature is now too low. The hot water heater, whether it be electric or natural gas, whatever, is now going to come on, and it's going to heat up that water until the thermostat is satisfied. Let's just say 120 degrees Fahrenheit. But you have a pressure reducing valve and you have a closed system, you're in a static state. Water is non-compressible, so what happens is that now by heating the water in the hot water heater, you are thermally expanding the water pressure within this side of the house. So instead of 50 psi, that pressure is going to go up depending upon the size of your hot water heater and whether or not you have an expansion tank installed or not. So depending upon the accessories of your system will determine exactly how the thermal expansion pressure will be realized. Now, in the drawing that I have behind you here, I've got a before and I've got an after. So I'm in the process of changing out my pressure reducing valve, but I haven't changed it out yet. So I'm going to go through the steps of how I did my troubleshooting, and then I'll show you, and then you'll see the numbers before and after, what the difference makes. And then me, as the homeowner, will be able to see how the water in the house is different than the way I've been living with it for years. So anyways, I'm just trying to get it so that the system is 100%. And I want to see how much difference it's actually going to make. Now, so there's several things here that I'm going to, several numbers here that I want to get. On that thermal expansion, I don't know if I explained that correctly, just going back to that one moment. So when you shut your shower off and you've got this pressure reducing valve set at 50, when you shut the shower off and that comes up, this pressure can come up to 100 psi or 150 psi or even more. Now on my hot water heater, there's, on all hot water heaters you're supposed to have this, which is a pressure temperature relief valve. So if the pressure or the temperature, I think the pressure is set at 150 psi, temperature 210 degrees Fahrenheit. If memory serves me correctly, I believe that's the settings. Once those are reached, then your pressure temperature relief valve will open and dissipate that pressure not to exceed it, so that your hot water heater is not at risk of blowing up like a bomb. So that's the way that works. So depending upon how much thermal expansion you got going on in your system, it's possible that you could pop that that pressure temperature relief valve and you could have water coming out of there because of thermal expansion. You may have a hot water expansion tank. It's supposed to be located on the cold water side right here. You might have a tank that comes down here, and that would be a hot water expansion tank. Maybe the diaphragm in that has failed and your pressure temperature relief valve used to not drip and leak on you, and now it is, and you're wondering what happened. Maybe the diaphragm inside there has failed. So we'll go through testing that out and all that. All right, so I took you into the garage, and there's my natural gas hot water heater behind me. There is a thermal expansion tank that I installed right there. Now if you look at it though, I've got it valved off, and I have it valved off for a reason. There's the valve that I installed, and you can see it's off, so you know it's not in service at this time, but it's ready to be put in service. Now the reason why I have it valved off is because my pressure reducing valve is completely shot. Now I'm going to show you how I determine that right now. So I want to start filling in this chart with before and afters on everything. Okay, another thing that I want to talk about is how that I determined what was the correct pressure in order to set up my system with. So some of the resources that I use is this. I have several books here. Big book of home how-to, and Stanley Complete Baths, and the Home Improvement 1, 2, 3 by the Home Depot. All three of these books do not tell you what pressure you should have inside your house. So here I am. I did a Google search, and the Google search was proper house water pressure, and then it populates with this information right here. It's the typical inlet water pressure to a home is 40 to 45 psi normally. It should not exceed 60. The pressure regulator is usually preset to 50 psi. However, it can be adjusted anywhere from 25 to 75 with the simple turn of a screw as shown. Okay, so that's talking about the pressure regulator. Now, let me show you what the pressure regulator that I purchased. Alright, here's the valve that I purchased to replace my existing valve. So this one here, I got it at the Home Depot for $111. There is the information, and I actually already got it. Here is the actual valve right here on my workbench, and this is what it looks like. This particular one is double unioned, so it's unioned on both ends, which is really nice to take it off and put it on. There's the model number right there, 70XLDUC. So anyways, that is the valve that I'm going to be installing and working with once I put it in my system. And there it is at the Home Depot website. I actually did buy it from the Home Depot for exactly that price, $111.81. And and I'm going to be sweating it in, so it's it's copper sweat is how it's going to be connected in. Now, one thing while I was searching for valves, here's a valve that I absolutely did consider purchasing. I thought it was kind of neat looking, But on this particular valve, which is an Apollo valve, excuse me, this is an Apollo valve. You cannot get this particular valve in 1 inch. And if you'll notice, it's not double unioned, it's only single unioned on one side. Thing that I like about this is that, look at that pressure gauge built into the valve, which is kind of nice. And it tells you the green zone. Let me just get this camera exactly right. So it tells you the green zone is somewhere between what looks to be about 45 psi and 75 psi. And this is meant for residential use. This is a valve meant for residential use. If you look at the valve writing, pressure reducing valve with gauge and so forth, but it's meant for a home. It's a pressure reducing valve for a home. And I had considered that, but my valve that I purchased is actually 1 inch because I'm dealing with a 1 inch line and I wanted to stay with 1 inch to give me the maximum water flow possible. So that's why I went with that. Now here's one of the tools that I am using in order to determine what my system is doing. This here is a pressure gauge. There is the model number to that pressure gauge right there. Hold on, come on camera, so that you can see that. And this is what it looks like. And I did purchase this at the Home Depot for like $15. And the thing that it has is it has this resettable handle. Hold on, let me get a better picture. Okay, so what it has is it has this resettable hand. You turn that and you set that down to 0 or whatever. When the pressure comes up, it will, and the pressure comes back down, this will tell you where it ends up resting, to tell you what your highest pressure is, to tell you exactly what's going on. So that, and this one, I started off with the cheap one, which was a $10 valve, $10 pressure gauge, and that thing was so poor quality that I returned it immediately. This is cost me 15 bucks, but this is much higher quality. This quality is acceptable, and I can live. This is the quality that what I want. So now I'm gonna fill in my chart. Okay, so the first thing I want to do to fill in my chart is put the pressure gauge on, and we want to figure out what the street pressure, house static pressure, and then running water through plumbing fixtures. And I got 1 fixture on, 2 fixtures on, 3 fixtures on, and then what the thermal expansion pressure is. And let's go through the whole thing right now. Okay, so here we are on the outside of the house. This is the section that I'm going to be redoing. Now, what's happening is the water comes in from the street here, goes through one main shutoff valve, which is the old gate style valve here. Then it tees off, and it goes from 1 inch, and it tees off to 3/4 of an inch. It goes through a 3/4 inch ball valve here, changes over to PVC, and then that goes to the irrigation system. Here it comes up, it goes through the pressure reducing valve that is no longer functioning properly, comes up, has a hose bib valve here, and then it goes into the house here at 1 inch. Okay, so you can see that I've got my gauge on there, and you can see exactly what the pressure is. So I've already got that valve opened up, and there is your pressure, which, let's just call it 110 psi. Now, on my particular situation is so what I'm going to do now is I'm going to call I'll tell you what I'm going to do. I'll open up the cold water faucet on the downstairs sink. Okay, so right now I'm running the cold water on one faucet, and you see that I dropped down to 65 psi. Now I'm going to open up a second, there's a tub downstairs. I'm going to open that up. Okay, with the tub on now, it dropped down to just like 61 psi. Now I'm going to flush a toilet. Alright, now I'm flushing a toilet, and it's pretty much staying right at 60 psi with 3 fixtures on. So it went from pretty much 65 to 62 to 60. Now I'm going to shut off those 3 fixtures. Okay, I've shut off the 3 fixtures and I put the hot water heater in vacation mode, so there's no way that that can be thermal expansion. So right now the house static pressure is at 110 psi. Now what we want to do is we want to figure out what the thermal expansion pressure is going to be. So we need to get the hot water heater going. Alright, so here's our chart so far. Street pressure, I put a question mark because I don't have a tap before the street pressure. The house static pressure is 110 psi, which I'm assuming is street pressure, by the way. The fixture, with 1 fixture on, we saw it at 65 psi, 2 fixtures was 62, and 3 fixtures was 60. Thermal expansion, that's what I'm after right now, is the thermal expansion pressure. I still have the valve here is off, and I have my hot water heater on vacation mode. So what I want to do is I want to jack that up, get that going. Alright, I got it all the way on hot, but it hasn't kicked on yet. I'm going to run some hot water to try to deplete the tank. Alright, so here I'm going to open up the hot water valve. That water there is going to be good and hot. And we want to get this hot water heater to fire off. Normally I set that right on hot. I'm going to leave that on hot. And let's see if we can get this thing going. I don't know if I'll be able to see it or not. See if I can see the pilot. This particular one is a pilot system. I can't even see that. Hold on. I shut the camera off and 2 seconds later it turned on. Alright, let me shut off the hot water so that way this... Alright, I'm going to shut this valve off. There we go. And now the don't need that. So what I'm going to do now is the hot water heater, we're in a static condition. The hot water heater is on. Now I'm going to wait till that thermostat gets satisfied, and I'm going to see what the pressure is outside. Alright, I've instructed everybody in the house not to use any water, and the flame is still on, and I'm just waiting for the thermostat to get satisfied, so this way all the thermal expansion will have taken place. Let's go outside and see what the gauge is doing now while it's fired up. Alright, so you can see that I am just about, well, maybe 112 psi on this gauge with the hot water heater fired off. So what's happening is the thermal expansion feature of the pressure reducing valve, which is right there behind it. Oh, hey there. Do you want to say anything?
Hi.
Alright, thank you. Alright, so the thermal expansion feature of the valve is what it's doing is it's bypassing the valve, allowing that pressure that's building up in the system due to thermal expansion, it's allowing it to go back into the street to so let's just hypothetically say that the street pressure is 109 psi. Then what's happening is that about 3 psi or 2 to 3 psi over that is when the valve is bypassing and allowing that excess pressure to go back into the street. Let's see if the hot water heater has backed off. You can see that see where that red is? You can see that that's already backed off. The needle is backed off slightly from where the red is. The the hot water heater may be satisfied now. No, we're still fired off here. I'm still waiting for this thing to get satisfied. Gotta wait a little bit longer. I want to see it through right till the very end. Okay, the hot water heater's still fired off. Well, since it's fired off and I've got a few minutes to kill, what I'm going to do is I'm just going to check the draft on this. Let me fire this thing off here, hold on. So what I'm doing is I'm creating a little bit of fire, a little bit of smoke here, and then I'm taking this and putting it here to see if it gets sucked into the draft. Not as well as I'd like. It is drafting in. I wish it was a little bit better. Let me just try that again. So I create some smoke. Put the smoke right near it. Yeah, it's drafting in. It's not the strongest draft, but not strong at all. Some of it's actually coming out. When it's directly underneath, it does seem to go right in, but when I had it out here a little bit, it's not strong enough to draft it in. So there is a draft, it's just not a strong draft. The pipe here is a vent pipe. I did not install this, so I'm just assuming that it is the correct size. Let's see here. Yeah, looking at the top tail piece here, actually I'm not sure the exact name of this piece. It does appear to be the correct pipe diameter coming out of this, and it is pitched up, so it's not like there's like negative pitch on the pipe and then it goes up to the roof and out from there. So anyways, just while I'm just waiting for this thing to get satisfied, I was a little bored, so I thought, well, I might as well just go ahead and check the draft while I'm up here. One other thing I did, you can see this pipe is fairly new here. This one here on the hot water side, you know it's hot because of the color red. The other one's blue, which is cold. And I installed a valve on that side of the system. So I actually have valves on both sides, the cold water side, hot water side, and then a separate valve going to this expansion tank. This is a Watts tank, and there's some pressures here for this particular tank. There's the model number of the tank, and the air pre-charge pressure was 40, max air charge is 80, and so forth. Okay, so that is everything to do with that, and I'm still waiting for this thing to get satisfied so I can check my thermal expansion. I'll see what the pressure is outside. There's your pressure. Still not really doing anything. It's about 110 psi, 111 psi. So there was a little bit of a spike there. You can see my red where it came up to, oh, let's just call it 117, and then it backed off and it's not going any higher. Maybe the street pressure is backed off at this time, and that's why it doesn't require as much pressure, because I believe the way the thermal expansion works on this pressure reducing valve here is that it's about 2 to 3 psi over street pressure. So it's possible the street pressure was up at one point in time, and that is what did that. So I don't think we're going to go any higher, but I want to wait till the thermostat is satisfied. Okay, the thermostat is satisfied, flame is off. Let's go check pressure outside. Alright, there you go. Pressure is about 110 psi, but I'm going to call that a high of a little hard to read it, what that is. Hold on. I'm going to call that 115. 115 psi thermal expansion. Okay, so here's our chart filled out. And you'll see that what I've got here, I'm going to assume the street pressure is 110 psi or thereabouts, between 110 and 115. Let's just call it 110. With one fixture on, now I'm running water 65, 62, and 60, and thermal expansion is approximately 115 psi. Of course, this depends on what the city is providing, because this is going to go 2 to 3 psi over whatever the street pressure is. Now, even with me changing out the pressure reducing valve, what do I expect to accomplish? Well, number one, the pressure that I'm planning on setting my my pressure to is actually, I'm thinking about going with 60 psi, and let me explain why. The reason why is because right now you'll see that on the way that the pressure comes in, the water comes in, and then it goes over to here, and then it goes to the irrigation. So my irrigation is getting a pressure of 110 psi. The irrigation, from the research that I've done, should get a pressure somewhere between, well, let's just call it, I'll tell you what, let's just call it like this, 30 to 60. That's what it should be. Here's my problem. On one of my zones, I have 6 zones. One of the zones has a large number of heads, and I'm afraid that it's not going to work properly at 30, so I got a feeling I'm going to need the 60. What I'll do is I'll start out at 50, I'll see if it works fine, and then if not, I can always increase it to 60. So I'm going to, all right, so I'll tell you what, I'll go for 50 psi is what my starting pressure will be. So if I do this correctly, and if this valve is working properly, my expectation is that I'm going to have 50. With the second fixture on, it'll go to about 47. With the third fixture on, it'll go to about 45 psi. So this isn't really going to drastically change with water flowing. It's going to be approximately the same. Now, my house static pressure, I expect that to be at 50 psi. Thermal expansion, because I'm going to be introducing this tank into the equation, I expect the thermal expansion to be approximately, let's just say 53 psi. And at that point in time, I'll know what my street pressure is, but I'm going to guess and say it's 110. So the only things that I'm really accomplishing with me doing this valve change out for the pressure reducing valve, what I'm accomplishing is I'm taking my house static pressure from 110 down to 50, which is good, I'm cutting it in half, and I'm taking my thermal expansion from 115 and knocking that down to 53, which is, again, is good. The house is going to be experiencing lower pressures than what it's at now, and I'll have control over this because the PRV at that point will be working. And I'm repiping this so this way the irrigation is no longer going to be on this side. I'm going to take the irrigation and take it off of this side. So the PRV that feeds the house is also going to be the same PRV that feeds the irrigation. So the irrigation was receiving 110 psi on the inlet. That is now going to be receiving 50 psi. So this is the changes that I'm going to be making in the system. Now, with these changes that I'm making into the system, they are certainly not inexpensive to do this. The valve, that was $100. That tank, I think that was $63. The copper, to do the whole job, I probably spent at least $250 in copper. At least $200. At least $200. So this whole job is costing me, just in materials, at least $350 to accomplish this goal. Not to mention my labor and the research in order to make sure that I'm doing everything appropriately. So anyways, so those aren't, once I do the change of the new system, we'll go through and we'll do the same test. We'll get the real numbers down. I'm just telling you what my expectation is to happen, and my reasons behind it, and why I'm doing it, and everything. And like I said, now I've been living in this house for 7 years, and that pressure reducing valve has been in the same condition it's at now for the same 7 years. I'm sure of it. It was failed the day I moved into this, and we just used the water in the house like a normal house. I mean, no difference. Now, I have experienced one irrigation problem the time that I've been here. Oh, and one plumbing problem. Okay, so that pipe up there, that copper pipe that's on the hot side of the hot water heater, that leaked on me once. I replaced that. And on the irrigation system in the back of the house, I have a drip on one of the zones. It goes through a pressure reducing valve, and then it goes into a drip system. And then I think it was on the downstream side of that, after the pressure reducing valve, that half-inch black plastic tubing just burst. So this is definitely going to help that too. But that only did happen to me once, and I patched it up, and it's still working. It's just this is the items that the house has experienced. And one other thing, this particular house is in Orange County, California, and everybody in this neighborhood, when they built these houses, they took the copper water supply coming in, and they ran copper lines in the slab of the home. So my home is same thing. It's got some copper in the slab, and this area they call it Orange County because all they grew was orange trees. The ground is extremely acidic, and that acidity and the age of the house and everything has come up with plumbing problems, and what happens is the plumbing fails in the slab a lot of times, and then you have a slab leak, and depending upon where that slab leak is located, where it's a huge issue depending upon the break, when you find it, how bad it is, and all that. Some people, you can have $20,000 worth of damage as a result of that. So a lot of people are converting over to PEX. That's one way to do it. Get the copper out of the ground and get it up above the ground. And then they don't even go copper. You can go copper, but a lot of people don't. They just go with PEX, which appears to be a good product. I don't have any experience with PEX, but it appears to be good. I guess the reviews seem solid. That's one thing. One other neighbor, what they did, instead of going with PEX, what they did was these plumbing companies says, what we'll do is, you don't have to convert over to PEX. What we'll do is we'll take your existing copper and we'll coat the inside, and you'll get another 40, 50 years out of it, or something like that. It cost him, I believe, $10,000 for that. But the advantage of doing that as opposed to PEX is that person did not have to open up their walls, because they could just access the plumbing fixture, the plumbing valves, the sinks, the faucets, the toilets, and all that stuff where it was easily accessible. And then the plumbing company, I guess, circulates a epoxy resin, I guess, and they epoxy coat the inside of the pipe. And it doesn't drastically reduce that, and it comes with, I believe, a 10-year warranty. So that's another alternative. But that's the different technology and all that. Completely different than the PEX, because you're doing an epoxy coating. Okay, so I kind of went through everything with you folks. I went through the reasons behind it, what I'm doing, what I'm trying to accomplish. Oh, and let me explain one last thing. The reason why I left that valve in the off position on the thermal expansion tank is because if I was to turn it on, what would happen, because my pressure reducing valve is malfunctioning, my house static pressure would go up to 110 psi. I'd be subjecting that diaphragm to 110 psi. And in the thermal expansion tank isn't really meant for 110 psi. I could potentially have the diaphragm fail. Let me see if it says what pressure the max is. Hold on. Actually, it could take it. It says that the max working pressure is 150 psi. The max air charge is 80. So I technically would not kill the diaphragm in that tank, but the thermal expansion would not be working properly in that tank. It would just be going out the bypass, out the pressure reducing valve. So it's not really beneficial for me with a malfunctioning pressure reducing valve to put that tank in service. So because my PRV is shot, these are my pressures, it doesn't make sense to put that in service right now. Okay, so what I did was I drew out the existing system and what it looked like, where everything was located, and just kind of went through that. Then I drew out exactly the system that I wanted to design. And now what I've done is I've pretty much just laid it out here on this workbench. So what I'm going to do is I'm going to take the incoming 1-inch line. I got a ball valve here with a bleed port. I'm going to install the bleed port, or the drain port, on the house side of this system. Make a 90-degree bend, go through a T-fitting 1-inch to half-inch, and then there's a half-inch valve here where I can install this. With this gauge here, I'll be able to determine exactly what the street pressure is and what the high of the day is and all of that. So that's the benefit of me putting a tap in before the PRV. Then the PRV, then I'm going to put in another T, 1-inch, half-inch valve to hose bib. And then I have another gauge here so I can determine what the pressure differential is and make sure that I'm getting the right pressure going into the residence. Then I'm going to come over to this T, 1-inch to 3/4, and then I have a 3/4 inch to male, sweat to male adapter. And then that ball valve that's on the system now is going to go right here to the irrigation. We're going to come from this 1-inch up to this 90-degree 1-inch. I was considering putting in this T. I got a 1-inch T, but I don't think I need this T at all, because this is a double union right here, and because that's a double union, it's going to be so easy to work and change out this valve. I don't even think I need an additional union in this pipe here at all. So I'm not even going to put it in. I'm going to come over. I got another 1-inch valve here, sweat, everything's sweated. I got a bleed port. I'm going to put that on this side. So this way, if I want to work on the system, I can drain out my pressures here, at this bleed port, and at that bleed port, draining the line down, and everything will be shut off. I'm going to have a shut-off valve here to shut off to the irrigation as well as to the house. You're going to have a shut-off valve to shut off just the irrigation here, and you're going to have a shut-off valve here to shut off just the house. So when I go on vacation, what I can do is I can shut that valve off, put the hot water heater on vacation mode, and leave the irrigation system on, so this way the house is not in jeopardy of a water malfunction while I'm on vacation. So that is this. I don't have the ability to do this now, because what they've done is they have one valve here. This valve is not here on the existing system, and then you have one valve here. So if I go on vacation, if I shut this valve off here, it shuts off the irrigation as well as the house. By putting this additional valve in, now I can just shut the house off and leave the irrigation alone. So that's the game plan, and I got to start getting it all, put all the pieces together. Okay, here is the final product. So we come out of the ground, we go through a nice shutoff valve there, and you'll notice I've got a bleed port that is located right there on the house side of the valve, right there if I want to bleed that down for any reason. I have that ability. After that, we do a 90-degree turn. We go through a pressure, through a hose bib valve, and there is your pressure of the street. Now you'll notice that the pressure of the street is 110 psi currently, and you'll notice that I've got the red gauge on it. When I take my water, oh, you can see that bouncing around. Someone must have used something inside the house just a second ago. Okay, I got a hose attached with the spray nozzle right here. So what I'm going to do, just to show you an example, is I'm going to take this and I'm going to shoot that while you're looking at that gauge to show you how that fluctuates. So, and let me show you. Hang on, let me zoom in so you can see it real tight. And I get you right there. Okay, so here I am. You can probably hear the valve in the background, but see how it bounces around? And that's why that red needle, even if I reset that, even if I take this and reset that to where it's at, if I take and bounce this water around and then just cycle that, it keeps pushing that over. Now I've been leaving this on for like a week, and sometimes actually I've seen it as high as all the way down here. Now that goes up to 160, so at some points during the evening it bounces all the way to over 160 psi. Okay? Alright, so anyways, that's the house street pressure. Then we go through our brand new pressure reducing valve. Then we come over here and we have house pressure. Okay, now on the house pressure, I currently have it set at about 70 psi. I had it set originally at 60 psi, and I was trying that, and I was having a problem with one of my irrigation zones, well, two of my zones, and I'll show you those in a second. After that tap right there, we come down, we go through this 3/4 inch ball valve which goes to the irrigation, and then we tee off, and then we come up 1 inch, come across, and then we have a shut-off valve right there, and you can't quite notice it in that picture. Hold on. But right there I've got a bleed valve on this side of the system. So if I want to bleed off, if I want to shut this and bleed this down, I can. Alright, so with this system it allows me to do several things. I can shut this valve off here. That'll shut off everything. That'll shut off the irrigation and the house. I can shut off this valve right here. That just shuts off the irrigation. Or I can shut off this valve right here to shut off just the house and leave the irrigation on when I'm on vacation. That's the purpose for this valve. So, and with the way that I did this, I now know all my pressures. I know my street pressure and my house pressure. So that is why I designed and installed it the way that I did. And when you do this type of work and you have your irrigation tapped off of the same system, you want to make sure that your anti-siphon valves, the anti-siphon valve is this portion of the irrigation valve, this portion right here. That should be a minimum of 6 inches from the highest sprinkler head to here. So this particular one is the lowest out of the three. If I wouldn't mind redoing this and bringing it up between 6 and 12 inches, way up here. So if you do replace these valves, don't keep them low to the ground. Get them up between, so that the anti-siphon valve is between 6 and 12 inches above the highest sprinkler head. Okay, so now that you know that, let me show you my zone that I had a problem with. Okay, here's the portion of the backyard, but here's the sprinkler valves. The one in the middle, that's the one that is the problem zone. So what I'm gonna do is I'm gonna turn it on manually, like this, and that's gonna turn on the sprinkler zone. And let me go show you that sprinkler zone right now. So I've already counted this up. This particular sprinkler zone has 18 sprinkler heads. Now I did not design this. I purchased the house with all these zones, but first of all, 18 is way too many. You should never go over 10, 12 maximum. So 18 is ridiculous. So like I said, I did not design this. So I increased the pressure to 70 from 60 because I wanted to try to get the best coverage here. I still seem to be a little weak back in that corner right over there, but I'm going to let it go for now, and I'm going to see how things turn out. So that was one reason why I went to 70. And by the way, in case you're asking, this valve here, right here, which controls the flow going through the valve, is all the way backed out. So it's the maximum flow going through the valve is what I've got going on right there. All right, so just to give you an FYI on that. Okay, so now I'm going to show you the other irrigation zone that I've got. On this side of the house, you've got, I'm using a drip irrigation system. So you can see I've got these agapanthus and pygmy palm trees here. So let me show you what I'm talking about. So inside here is a drip irrigation system where I've got these sprinkler heads. Now, before, this pressure used to be city pressure. When you took this off, this cap off, this was, I mean, it was shooting out of there, you know, at 110 psi. And sometimes I'd even lose these caps. But at 60 psi, this is the end of the run, by the way. At 60 psi, when I went to go put this on, it was, I mean, it was just a dribble. Right now, I got it at, even at 70 psi, I mean, I really don't want to go any less than that. So that's still going to be enough to irrigate this, but you know, so there's two reasons why I went to 70 psi. This zone, which is zone 4, and zone 6, which is that one in the back with the 18 heads. Now zone 6, that particular zone should be rezoned. Zone 6, technically what I should do is I should dig that up and break that up into 2 zones. If I did that, I could probably drop my PRV valve back down to 60 for that zone and be okay. I'd still be weak over here unless I possibly divided this zone up into 2 zones as well, this drip irrigation system. But I'm just going to leave it at 70. I'm going to see how everything reacts to with that. So with that, I'm hoping that I'm going to be okay. Now the last thing we need to do is we need to check the expansion tank next to the hot water heater, check that pressure and adjust it to 70 psi, which is my new PRV setting. So we're going to do that right now. Oh, and plus we have to continue filling out that chart. All right, here's my chart, and you'll see those are my original before pressures, and then on my after pressures, those numbers that you see there were my assumptions that I was going to do for my system. But I ended up not going with 50. I jacked that one up all the way to 70. So what I'm going to do now is I'm going to go ahead and fill in the chart with the actual numbers. Okay, here are my numbers that I did for my test. So this column here is what my guess numbers are. These numbers here are the actual numbers. So the street pressure coming into the house is 110 psi. The house static pressure, I originally had it set for 60 psi, but I raised it to 73 because of that irrigation zone in the back being a little weak. I tried to get it to 70, but it kind of rested out about 73. So when I did my flow tests with one fixture on, when we started on the before, it was at 65. I got it actually up to 70 now with one fixture running. and with 2 fixtures running it was 62, now it's 66, and with 3 fixtures running it was 60, now it's 65. So from the house perspective, the pressures are increased by about 5 psi. Now, I have not done the thermal expansion yet, so we still have to do that thermal expansion. So after I changed out the regulator, and my first pressure that I set it to was 60 psi, and the house operated just fine at 60 psi. That back irrigation zone, the one that has 18 sprinkler heads, out of all the sprinkler heads that I have, I mean all the zones that I have, that was the only zone that did not operate properly. And that's really a design flaw in the sprinkler, the irrigation sprinkler system. If that system had been designed properly and you had not exceeded, let's say, 10 heads in one zone, then everything, the house and the irrigation would have all worked fine with 60 psi. So here are my options. My options are to redesign the irrigation sprinkler system so that I can irrigate that zone and do it with 9 heads or something like that, and make sure that I can irrigate the area with the less heads and so forth. But I have to redesign that, and so that's one option that I can do. Another option that I could do is I could repipe my inlet water supply so that I have one pressure reducing valve for the irrigation and one pressure reducing valve for the home. That's another option. So the easiest option for me was to just simply take the first option, which I chose to do, which was the easiest option, was to just take my pressure reducing valve and raise the pressure, the static pressure, from 60. I tried to go to 70, but it kind of creeped up to right about 72, 73. And just try that and then see how everything reacts. If that zone in the back irrigates properly at 70 psi, I don't even have to do anything. So my job is done at that point in time. I'm just trying to explain why I did what I did. Now there's let me show you some more information. So if you remember back at the beginning of the video, I just did a Google search, correct water pressure to a house, and it tells you that the correct water pressure is typically 40 to 45 psi, and normally should not exceed 60 psi. So that's where I got the 60 psi from. So that's one pressure on one generic Google search. But if you go over and look at this valve here, which is one of the valves I was considering purchasing, and you look at that pressure gauge built into this particular, what is it, an Apollo valve? Yeah, this is an Apollo 3/4 inch lead-free bronze pressure reducing valve with gauge. Now if you look at that gauge pressure, you'll see that the green zone goes all the way up to 75 psi. Again, I tried to get mine right around 70 and it creeped up to about 73. So according to this from Apollo, I'm at the upper end of the range, but still green. Okay, so that's using that reference source. Now here's a book about home inspection, okay? And this is the complete guide to home inspection. And when I open that up and I look at water flows and pressures, alright, now looking in the book here, it tells you that pressures between 40 and 80 psi are in the normal range. Okay, so this is just utilizing this book here, which is a home inspection book. That reference is telling me that I can go all the way up to 80 psi. So those are different reference materials. Alright, so with that in mind, my house static pressure of 73 psi is towards the upper end. I I don't necessarily want to go higher than that, but everything I should still be okay. All right, so that's how I arrived at determining that that was the pressure that I wanted to live with. The house would be just fine with 60 psi, like I said earlier, but I'm going to, because I want to see if I can irrigate that back zone without redesigning it, I just increased the pressure to see if I could do and accommodate and make all worlds happy simultaneously. So this is the easiest solution without me spending any more money, time, energy, resources to try to fix that back zone. Okay, so that is the reasons behind all of that. Now, we need to check and do the thermal expansion. This is the last item that I want to get into. There's a couple different thermal expansions. Number one, I've got thermal expansion right here in this tank. So that's one thing that I can do. Number two, I want to check the new valve and verify that the thermal expansion bypass works on the new valve. So we need to go through the entire situation. The first thing I want to do is I want to check my thermal expansion on this tank right here. So how do I do that? I know that my house static pressure is 73 psi. So the first thing I want to do is I want to get that tank to what's referred to as a zero static state, and I want to verify that the pressure on this port right here at the bottom port, which normally has this blue thing on it here, cap, I want to make sure that that is 73 psi. So the first thing I got to do is I got to get the water pressure off of that. Now I have a shutoff valve up there with the bleed screw to make sure that I can do that. But if I just shut that off and open that bleed screw, I still have about 73 psi of pressure on this side, and all that water is going to discharge into my wall and stuff. And I don't want to do that. I want the least amount of water in the garage as possible. So this is the process that I'm going to do. First thing I'm going to do is I'm going to shut off the inlet water supply. Oh, you know what I'll do? First thing I'll do is I'll take the port here and make sure that it doesn't fire off, and I'm just going to go ahead and put it to vacation mode. So I don't have to worry about the hot water heater firing off. Next thing I'm going to do is I'm going to shut that valve right there. Let's get this is the inlet water supply to the hot water heater. That's this one. I'm going to shut that off. That's going to kill the inlet water to the hot water heater. Then what I'm going to do, okay, that's shut tight. Now what I'm going to do is I'm going to go to a sink. I'm going to open up the hot water. Let's go do that right now. Okay, so here's a sink. When you're looking at a sink, the one on the right is cold, the one on the left is hot. I'm going to open that up. Now that pressure that you're seeing right there is the pressure from that expansion tank. That's what that should be, because all I have is the hot on. Look at all that water. That's an enormous amount of water that would be coming out that bleed screw, which I don't want that to happen. That's why I'm doing this, because I don't want to deal with all that pressure coming down my wall into my garage. Look at that, that's still running. Unbelievable. I can't believe how long this thing is running for. I almost get the impression that I didn't shut that shutoff valve tight, but I'm sure I did. Wow. Look at that. All that time. Finally down to a dribble. That was a lot of water. Did you see all that water? I guess it makes sense. Alright. Now you'll notice I'm down to just a dribble, dribble, dribble. I mean, I've got very little pressure here. So now, let me show you what I'm going to do. Now shut that off. Let's go back out to the garage. And on my situation, I've got a tank outlet valve. I can shut that off. Boom. Now what I can do is I can take this pop-it valve here and I can pop that and make sure that there's no pressure there, and there is not. Now I can open this up, and okay, I started to get a little bit of water out the overflow. Now I just shut that. Now I can shut that right there, and now this is vented to the atmosphere. This tank right now has got only atmospheric pressure on the top of it because I've got this valve closed and I've got my bleed screw opened, and I'm totally good to go. I've now isolated this tank. So now what I can do is I've got a pressure gauge here, but this particular pressure gauge that I have only goes up to 50 psi, which is for automotive tires here. See if we can see that. It's kind of, anyways, this thing only goes up to 50, okay? So I know I want 73 psi. So what I got to do is I got to use my bicycle tire pump. This particular gauge goes way up past 120, okay? So let me put this thing on the tripod. Let's take this, put this in here, open that up. And the pressure right now is 69 psi. So if I'm supposed to have this balanced at 73, technically I need to put 4 pounds in here. All right, it's going to take me a second in order to do that. What I'm going to have to do is I'm going to have to start up my air compressor I got under here and get some hoses and stuff. All right, there's the pressure. Let's see if I can get it. Oh, come on. Trying to show you that pressure. Anyways, it's just over 70 psi. The camera loses focus when it goes in too tight. Okay. Now that we know that we've got the correct pressure on the tank that's matching the system pressure, I'm going to go ahead and shut that off. And let me dry this up a little bit. And let me find my bleed screw. I hope I didn't lose that. Are you up here? Yes, you are. Alright, so now I'll put the bleed screw back on here. Tighten that up. Now I'm going to open this up. And if you can hear that, this tank is being charged up now with the static water pressure of the house. And we're there. So this should pretty much be in balance right now. 72, 73 psi in the bottom, 72, 73 psi in the top. So this is all balanced out. I've already opened up this valve. I've opened up this valve. Now, what we want to do is we're going to put on our hot water heater to hot, and we need to get the flame to come on. So what I have to do is open up a hot water valve, get this flame to come on, and then check the thermal expansion with the tank. So we're going to do 2 thermal expansion tests. One is with the tank, which I'm assuming is going to give me no problem. Actually, you know what we could do? I'll tell you what. For the first test, we'll do without the tank. Leave that shut. So for the first test, what we'll do is we'll test the thermal expansion bypass at the regulator. Make sure that works. But I got my hot water heater on. I put this back to the thermostat setting here, back to hot. So what I need to do is I need to open up a hot water valve, get this thing fired off. I'm going to do that right now. Okay, I've got a hot water valve opened up, and you'll see that I'm dripping out of here. That's my pressure temperature relief valve. Well, on my particular heater, because it's so old, this thing has an install date between... Oh, that thing just fired off. Let me go shut the water off. shut that off. Okay, this flame is on and that valve is closed. Let's go outside and check our pressure. Okay, so from the city side, it's 110, and on the other side, it's about 75 psi. So let's see what happens now, because there's no thermal expansion in the house because I shut that tank off. So what should happen is that this pressure here should come up due to thermal expansion. We're going to test that right now and see what happens. So I'm going to give it a few minutes. Okay, it's been a few minutes. We're at about 85, 86 psi. The hot water heater still fired off. Alright, it's been a few more minutes. Hot water heater still fired up. And you can see we're at 100 psi on the house side of the pressure. Your city pressure coming in about 110, 111 psi. So we still haven't used any thermal expansion bypass of that valve. It's just heating, it's just building up the pressure on the house side. This pressure has to exceed this pressure over here in order for it to utilize the internal thermal bypass of that pressure reducing valve. So this has got to get over 110 psi. It has not done so yet, so we're just going to sit here and watch it. It's got about another 6 psi to go, so we'll give it a few more minutes and see if we get there. Okay, we are finally at 110 psi on the house side. So you've got 110 psi on that gauge. You've got 110 psi on that gauge. So now we need to monitor this one and see if that pressure begins to stop rising and settle out. If that's the case, now the thermal expansion of the thermal expansion bypass of the PRV valve right there is then going to be taking place, and a small amount of pressure is going to be going from here back into the city to alleviate this pressure. That's called thermal expansion. So we're going to keep monitoring this. I've got my red needle on there also to watch it to see exactly what it's going to do. So right now you can see that we're okay at about 110 psi. Somebody must have used hot water in the house. I forgot to tell them not to use the hot water, so it just messed me up. I'm gonna have to start the test all over again. Okay, so I had to start the test over again. So right now I've got the expansion tank shut-off valve shut and the hot water heater is fired off, so it's building up pressure. So while I was out here and I'm just kind of observing everything that's going on, I actually saw a drip dripping over here down to the ground. So I thought maybe it was this bleed screw, because you can actually see a little bit of water on that bleed screw. But I was looking at it and it's not the bleed screw, it's actually a joint up here. I'll show it to you. Alright, so here you can see some water at the bottom of that elbow, and right there, right on the back side of this thing, oops, that got me a little bit of a seeper. Well, I gotta resolder that joint, but right now I don't want to resolder it. I want to get my testing done. So I'm just gonna do that following this. But right now, I got all the way up to 110 psi before the test got canceled because she used the hot water. All right, so I just have to wait now until this thing comes up. Okay, we're getting up to the point where the test got canceled last time because the water was used. So we're getting right back to that inflection point, 110 psi. and let's just see if how much higher we go. So I just have to give it some more time. So that's the house side. Over here is the street side, 110 psi, and this is the one that we're watching here to see what this is going to do. So we're about at 111 psi. Alright, so we're just going to monitor that. I'm going to give it a few minutes. Let me go see if the hot water heater is still fired off. Hot water heater is still fired off. We're at 111, 110 psi. I'm going to say the thermal expansion is definitely working because the pressure is not exceeding that. 110 psi there, and 110, 111 psi. So it's about 1 pound over is when the thermal expansion of the valve works. But what I'm going to do is I'm going to keep the test active until that hot water heater completely shuts off. Okay, we just shut off. I'm going to go outside right now and check the pressure. Alright, so here you go. And you can see I've got my red needle seat on there, so we know that we never exceeded about 112 psi. So the thermal expansion bypass of that valve is working properly. So now let's put down as our pressure 112 psi. Alright, so without the tank, the thermal expansion is 112 psi. Now I want to do it with the tank. So before I go ahead and open up that valve up there, I want to bleed off this hot water pressure, get that pressure back down to 70 psi. So let me do that. First thing I'm going to do is I'm going to open up the hot water valve right there. Let me check the outside pressure. Outside pressure has dropped off dramatically, so now I'm going to go ahead and open up the valve to the expansion tank by the hot water heater. Okay, now I'm going to go ahead and open this up. Which we already know that's set to about 72 psi. So now that we've done that, now that tank is back in service. Okay, the hot water heater is fired off. I'm going to shut the water off right now. So I got the water over here. Shut that off. That water's off. Okay, so now with the water off, we can see what the pressure is going to do on the system. We know the last time it went up to 110 psi without the tank. Now we have the tank on. Let's see exactly what it does. So right now we have to leave the system alone and let the hot water loop heat up until the hot water heater is satisfied. I can hear it, but just to try to give you YouTubers a visual, there's your flame right there. You can see that that's still on. So now I'm waiting for this flame to get satisfied and shut off that thermostat, so this way I can see what the pressure is. It's about 74 psi. So and it looks like it's probably not going to go higher than that, but I'm still watching it, see what's going on. Street pressure 110 psi, and boy, I better make sure I got that valve open. Yeah, it's open. Everything is open here. So this way I got clean pressures. All my valves are open 100%. All right, so I got to just keep an eye on that while I'm waiting, because it takes almost 20 minutes for that hot water heater to satisfy. I just got my wire wheel and got my heat, some solder, and some flux, so I could retouch this joint. And then I went around and cleaned it all up, so I can drain the system down once I'm done with this test. So I just got that joint ready to be touched. But for right now, I want to finish this test. Okay, thermostat just shut off. Let me go outside and check the pressure. 75. Okay, so you can see the huge difference here when you have the expansion tank. Instead of going up to about 111, 112 psi, you stop at 75. So let's go write that down. So with the tank, (75 psi). Originally, we were at 115. This is just a guess column, so you really can disregard this column. The real numbers are this column and this column. Alright, so let's go through it. Okay, so when we first started out, we could not tell our street pressure. I could only guess at it because I didn't have a pressure gauge on the street side. Now I do. I know what the actual street pressure is. The house static pressure was at 110 psi. I've got that reduced down to 73 psi. So under normal resting conditions, the pressure of all the pipes within the house are, 37 psi less than what it was. So it's a little bit less stress on the entire house, which is a good thing because of the copper in the slab of this house. The lower that pressure is, the less likelihood of a slab leak. Perfect example is that joint that when I was doing my thermal expansion test without the tank and I brought the house pressure up to 112 psi, under normal, in that joint that I showed you was a seeper over there, that one was not leaking at 73 psi, but at 112 psi, that joint was leaking. So that was like a weak link that hopefully I can fix. So that'll be my intention following this video. Okay, so house static pressure, I was able to reduce that. Now, that wasn't my goal. Was not to raise my pressures on my flows going to my house, because I was perfectly fine with those flows. Quite honestly, I was fine with 60 psi. This was raised because of an irrigation problem, because the zone was incorrectly designed. So because of an irrigation design problem and the same backflow preventer is feeding the house as well as the irrigation, that is why that pressure is 73. Otherwise it would be at 60. Okay, now how much difference does this tank make? Okay, and how do you test that tank and what's going on with that? Now you know exactly what that tank does and how to test it and to determine if there's any problems. If you don't have that tank, if you don't have an expansion tank like that on your cold water side of the hot water heater, your thermal expansion is going to go up, in my situation, to 112 psi before the thermal expansion bypass of the pressure reducing valve that I just installed bypasses and goes back into the street, which is what it's designed to do. That is working properly. If hypothetically, let's assume that my thermal expansion bypass on my brand new valve was not working properly, what would happen? Over here at my hot water heater, this line right here is connected to the P&T pressure temperature relief valve set at 150 psi. The pressure for the thermal expansion will go up to 150 psi. And then you'll drip out of this line and relieve the pressure that way. So if you have a leak, if you don't have one of these tanks, and you are dripping out of your pressure temperature relief valve at the bottom, that's an indication that the thermal expansion bypass feature on your pressure reducing valve or however you are taking care of thermal expansion at your property is not working properly, and you're leaving that pressure out of your pressure temperature relief valve. Do you want to do that? No, you don't. Generally, the pressure temperature relief valve is just an all-out safety feature indicating that the thermostat on the hot water heater has run away from you. The flame has come on. The pressure in the tank and the temperature is getting to the point where it's getting dangerous, like a bomb, and then it's supposed to relieve out. It's not meant to be used to take care of your thermal expansion, so please don't use it in that regards. But if you see it leaking, that's an indication that something's wrong with my plumbing system. I need to investigate. Okay, I mean, I'm giving you just about every single piece of information that you need to know in order to thoroughly go through your entire house plumbing supply water system to determine what in the world is going on with it, how to test it, and how it's supposed to work, and all this stuff. Okay, so now I did install this expansion tank, and what does my house do for thermal expansion under all normal operating conditions for me now? My pressure when I have thermal expansion goes up to 75 psi. Well, my house static pressure is 73 psi. It's only 2 psi differential, so it's like very mild to nothing. So all the pressure is being taken care of in the air pressure diaphragm that is located in that tank to take care of that thermal expansion, so it doesn't put the pressure on the plumbing system of the house. So I am good. I am good with all my numbers. I'm good with all my information. I'm good with everything. The only thing I'm not good with is that one seeping leak that I discovered during this testing phase. I guess that's a good time to say that, okay, a couple things. When you do your testing like I did, because it takes 20 minutes for that thermostat to come on and satisfy, the best bet for you to do is to have no one home in the house when you're doing this. So that way no one inadvertently opens up a sink and destroys your test and you got to start from scratch, which happened to me. So number one, try to have no one home at the house. If you do have people home, you have to inform them really strongly, do not use the hot water, because this is a hot water test. They could flush a toilet, it would not affect you, but what you don't want is you don't want a sink to be used that has hot water to open the hot water valve. Okay, so that's number one. Number two, if you do this testing that I did, and you could discover a weak link in your system. So my system did have a weak link, and I discovered it, and I'm going to fix that right after this. Also, another thing that I did when I was doing all this testing is that I popped that pressure temperature relief valve to relieve that pressure, because you saw how much water came out into the sink when I went to do this test, because even though and my particular system, most people don't even have this system. I went overboard with where my pressure gauges were. No one normally has the street pressure as well as the house pressure, as well as install and all. I got 3 valves on top of this hot water heater. One for the incoming cold, one for the incoming hot, and then one for that air expansion tank right there. The air expansion tank has a bleed port on it so that I can bleed the pressure out that way too. Most homes, most plumbers, I should say, want to install the fewest components possible because they want to do the job with the lowest material cost humanly possible. So with that in mind, they're probably not going to have all these shut-off valves that I have and the system designed the way that I did it. But because it's my residence and I'm the one that's doing the job, purchasing the materials, I want a very particular situation, and I have a reason for doing it this way. So this way I know all of my variables. The only way that I could possibly fill in this chart accurately is to do it with the system that I designed. Generally speaking, you know, that's why I designed it and did it this particular way. So I hope this video was informative. I hope you liked it, please give me a thumbs up. Generally speaking, this is going to conclude this video. What I'll do as a bonus feature is I'm going to go ahead and attack that seeper valve, that seeper leak. I'll go ahead and video it, and let's see how that comes out. You can subscribe to my channel. I've got plenty of other videos on a lot of different stuff. Alright, first thing I want to do, this is the joint that I got to hit right there, so I got to get the water out of this joint. So, let's see here, a couple ways that I can do this. What I can do, I've got a bleed port here, but that is on this side. I need to get this leg drained out. So I am going to have to shut this off right here. Let me go inside the house and open up a sink and get that water alleviated inside the house. I got all the pressure inside the house relieved. Let's open this up. Okay, that's good. Now I'm going to open up this bleeder port here. Put that bleeder screw up there. That was one of the nice things about installing these valves with bleeder ports. Is that I do have other ways that I can. I do have valves here that I can remove and get the pressure out of the line, but this is at the lowest point right here in the system, and so this is going to take care of all that water pressure there. So once I know that that is down to a zero static, then I know that that joint right there is not going to have any water in it. So let me let that drain out. While that's doing that, I'm going to leave this valve open here, and I only want to heat up this joint and retouch that, and I don't want to destroy a couple of things. I don't want this getting destroyed, so I'm just going to put a sock wrap on that, and I also don't want this valve getting too hot, so I'm going to put a sock wrap on that one too. And that's just to keep the pressure, I mean not the pressure, but the temperature out of these two valves. I don't like to heat up my valves. Pressure down here is down to 0. Let's start heating this joint and let's see if we can't get it soldered up here. We're good to go. This paste brush ready with some flux on it. I got my heat, I got my solder, and we're going to get this good and hot. The seeper was in the back. The most likelihood is that it's this joint, not this joint, that's leaking, because this joint is the existing T that the small pipe, and this is all brand new. So the probabilities of this joint being solid are better than the probabilities of that joint being compromised. This isn't going to work. I'm not getting the pipe hot enough with this product. I'm going to have to use acetylene. This ain't going to work. Sadly enough, I am not going to be able to do it with MAP gas. So I'm going to have to get some acetylene. I can tell that I'm not getting the pipe hot enough, and if I don't get the pipe hot enough, there's no way I'm going to be able to do this job. So I'm going to abandon. I don't have acetylene with me right here. I have to go get it. So that's it for now. All right. So what I did was I put on the bleeder screw here, opened up the valve. I got the street pressure back up on 110 psi. House pressure is currently at 70 psi. All the valves are open, and I went inside and purged out the water inside. This is that seeper right there. Hold on. and I'm looking for the seeper leak, and I don't see it. So who knows? I don't know. I was ready to fix something here, but I can't see. I can't see it. If I can't see it, I can't fix it. I'm gonna monitor it. Like I said, I don't have acetylene with me right now. If I have to, I'll get acetylene and get that pipe hot enough. I couldn't get it hot enough with this product, MAP gas. I just couldn't get it hot enough. I could tell by the way that the flux wasn't bubbling up. When you get your pipe good and hot, flux bubbles up nice, and this wasn't doing it. So I didn't feel confident about that. So I'm just going to monitor that. Alright, well, that is going to conclude this video. I hope you have enjoyed it. Hopefully you have a complete understanding about your own personal water supply system to your house, and you know how to test it, you know everything like that. So I hope that you got some information out of it. And that's it. Go ahead, subscribe, hit like. I'll see you later. Bye.